All right, in this video, we're just going to continue yesterday's notes. So remember that this is our graph. You should already have this. We're going to go ahead and go down to the last questions about this topic. Go ahead and copy these down if you don't have them already. Okay. For number 5, we have on what intervals is f of x increasing? And that means that when is the graph going up, like so. So what you're going to do is you want to go to your graph. I'm going to get some colors here. You want to label where the graph is going up. So I'm going to go back here to my graph, and I notice that it's going up right here. Okay, remember you read left to right, and it looks like that's it, because here it's going down, up, constant, down, and it goes down all the way through here. So the only place that the graph is increasing is between this point right here and this point. So what we do is we look at the x values there, which is -3 on this one, and this one is 0. Remember that the interval is asking specifically between what x values. Okay? So it's between -3 and 0. So I'm going to go ahead and write that down for number 5, -3, comma 0. And we put it in parentheses because if we put equal to, there's an actual pointer that equals something else, and that's not necessarily the case all the time. And we're going to go ahead and do the same thing for decreasing. And now we want to know when it's going down. So again, reading from left to right, where is the graph going down? So back here, from left to right, okay, we go this way. It's going down here, okay? Here it doesn't look like it's doing much. It's going down here, here, and all the way here. So it looks like it's going down in this piece right here and in this entire piece right here. Since this entire piece is connected, we're going to just do one piece for this one. So let's look at this one first. This would be these 2 points, which are these 2 x's. So between -5 and -3. So let's write that down on number 6. -5, comma, -3. And I'm going to go ahead and put that u because there are 2 of them, probably 2 pieces. Here's the other piece right here. So we do the same thing. We look at the x's, and it looks like it's 2 and 3. So between 2 and 5. Between 2 and 5, the graph is also decreasing. So 2, comma 5. And that's it. And the last one is asking us where is it constant, which means where is it just going across? And that's happening in one little spot right here. Between 1 and 2. So 1, comma 2. Okay, couple more questions. What I did is I went ahead and folded my paper in half, and I have some questions here on the back. So pause if you need to, and then write them down. Okay, it says define relative or local maximum. So this is just a maximum point that's kind of in between in a certain region. So I'm going to go ahead and put it in my own words here. Okay, it's the highest point on a graph in a specified domain, meaning it's only between 2 points or 2 areas. Okay, like between these 2 areas, what's the highest point in that spot? Okay, same thing with the minimum, but now it's going to be the lowest point. So the lowest point on a graph in a specified domain. So again, between 2 areas of the graph, what's the lowest point in that graph? Okay. What is absolute maximum? Okay. So absolute maximum means what's the highest point in the entire graph. So highest points in the entire graph. Okay, so just a lot of definitions so far on this back part. And same thing for the absolute minimum. Let me focus this a bit. It's the lowest point in the entire graph. So the difference in these definitions is that two of them, the entire graph, two of them are just on a part of the graph, okay? And the other two are in the entire graph in general, okay? So I'm gonna go ahead and just kind of go back to my graph and just identify where these are. If I were to say, give me a relative minimum in this area, well, you could say, well, this point looks like it's kind of like the lowest point in this area here, but this is your lowest point of all. So this right here would be a relative minimum. It's kind of like a minimum, but not the minimum, if that makes any sense, okay? This right here would be our global max, but in this case, since it's open, it wouldn't count. So it does have to be closed. So let's go ahead and make a note of that. So we could say could be absolute minimum is what I meant to say, not max. But needs to be a closed circle. Okay. So if this was a closed circle, then it definitely would be a absolute minimum, meaning it would be the lowest point in the entire graph. Okay. Let's see, for relative max, it looks like we don't really have any because these are both relative and maximum. So we could say this one right here is a relative maximum. And since it's also the highest point in the graph, it would also be the absolute. So it could happen where one point is both of them, absolute and relative. And the same would apply for these because it's the same value. Okay. Last but not least, there's a couple of definitions on here. Or not definitions, but questions. It says, on what intervals is f of x concave up? So where do you see either this happening, so this kind of curve, or this kind of curve happening? Okay. So let's see. Where is the graph kind of curving upward like that? Well, it looks like it's curving upward here, okay? This part is just a line, so that doesn't count. So this is one part where it's curving upward, and we're gonna look again at the x's because it's asking for the interval, so we always look at the x's for intervals. So it'd be -5 through -3, okay? So that would be the answer for this bottom one, number 12, -5 through -3, okay? And then it says on what intervals is it concave down? So where is it going the other way? Where is the bolt? I can't really show you the hand, but where is it going down? Okay. So it looks like that only happens in one area also. This is a line, 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 line. But this part looks like it's kind of curving down. So this would be my concave down right here between 4.5 and 5. So 4.5, comma 5. And that is it, guys. So we'll do some examples to kind of get this concept a little bit more thorough in class. Thanks.